All right, what is this symbol called? What do we call that? I'm hearing square root sign. Anybody else have an alternative option as to what we call this? Radical sign. I like the word radical sign better because it's more like encompassing of all the different types of roots we could do. If you would just call it a square root sign, then we are limited to only doing square roots. Are there other types of roots? We could do like third roots, fourth roots, fifth roots. Yeah. So we can't just call it a square root sign. It's called a radical sign. So it's important that we're going to use the proper terminology. Does anybody know what we call the number or the expression or the letters or whatever they are that's underneath that radical sign? This is a term that I have not heard very often in a math classroom, but I'm curious if anybody had a math teacher that used the proper term for this guy and didn't just call it the number under the radical sign. No? And maybe after we write it out, you'll be like, oh yeah, I remember that. It's called the radicand. You have, good, I'm glad there's some teachers using that terminology. It's called the radicand. The number that is up here in the corner, this is called the index. Now, we called it a square root sign, and the index is understood to be a 2 if you don't see anything written there. And that's why we all jump to square root sign. If you just see this symbol here, right, we all say square root of 9, right? Now, the index of that is a 2. We don't write a 2 every time that we want to write the square root of 9 because it's so common, right? The most common root that we do in math is a square root. And if we had to write a little index of 2 every single time we wanted to do a square root, our hands would probably fall off. So it's understood that this means the square root, and it has an index of 2. But we probably, as teachers, we never really say, hey guys, that's a square root of 2. That has an index of 2. We never really said that, did we? We never even mentioned that word index. But we kind of alluded to it whenever we get to a problem where we would say, hey, can you simplify like square root of 18? Do you remember what the process was? We'd make a little factor tree. Okay, and we would say what numbers multiplied 18? And we'd say 9 and 2, and then we'd break down the 9, 3 and 3. And then what would we look for? Pairs. We'd look for pairs. Did you ever wonder why you had to look for pairs? You just did what the teacher said? All right. It's because if the index is a 3, then we have to look for 3 of a kind. But this one is because the index is understood to be a 2. That's why you looked for pairs. Ah. So now, we might be looking at index numbers that are bigger than 2s. So maybe our index would be a 3, and we're looking for the third root of, let's say, I don't know. Okay, the third root of 9. All right. Let's do the third root of 9. Let's break it down. What do you get? 3 times 3. Okay. Now, the index is a 3. The 3 index says we're not looking for pairs anymore. We're looking for sets of 3. Do I have a set of 3? No, I don't. I don't have a set of 3 things. I have a pair of 3s. That's not a set of 3, right? So that means I can't break this down. The cube root of 9 is simply the cube root of 9. I can't break it down. I can't simplify it. But I could break down, let's say, the cube root of 54. Let's break down the cube root of 54. What do we have here? 2 and 27? And 3 times 9? 3 times 3? All right. So now I'm looking for Here's my set, right? What's going to be left over?
2.
The 2. I like to underline those so I don't lose them. Sometimes the trees get pretty big. And so my 3 comes out. My truddy, I like to call it that. Now, what did I leave out?
The index.
The index, you bet. Do you think you might lose a point if you leave out the index? Probably, because 3 root 2 is very, very different than 3 cube root of 2. Okay, so please be careful with that. Don't leave out your little index numbers. They are important. Okay? Does that make sense? All right. All right, next thing to talk about. Now, when we're dealing with these in this chapter, we're sticking to the real number system. We're not entering into imaginary number system. You're welcome. Right? So no I's here. So in the real number system, that means we could actually use our calculator and get an answer. So could you take the square root of negative 25 in the real number system?
That ain't real. That's fake.
That's fake. That's imaginary. Not really fake, but right? So not real. We're going to stick to the real number system only. Could you take the cube root, though, of negative 8? Is that allowed? Well, let's check it out on our calculators. Let's see how. And plus, I want to make sure everybody knows how to take larger than just square roots on your calculator. If you're using your phone calculator, you are able to do this as well. Just turn that phone sideways to get to your Android system should be able to do that too. If you're, I think you can.
Where's my calculator? My school.
As long as you get it to that scientific one. What you're looking for is a key that looks like this. I'm sorry. It's an X with a root. Something like this. Do you have a button like that? It usually has a radical sign with an X in the index position. And what you have to do is first you put in what your index is. So if you want a third root, you're going to put a 3 in first. Then you hit that button, the X radical sign. And then you hit the negative and then the 8. It will automatically put parentheses around that for you. And then you hit equals. And are you getting negative 2? Yeah? Yeah? So what that means is if you take negative 2 times negative 2 times negative 2, you should get negative 8. That's what that means. And that certainly does happen, right? If you take a negative number and you multiply it by itself an odd number of times, shouldn't you get a negative number? Mm-hmm. And if you multiply it by itself an even number of times, you should always get a positive number. Does that make sense? Okay. All right, you need some milk? I'll pause that. All right, so let's make a table here of what happens. Just go. Of what happens depending if our index is even or odd, and our radicand, if it's positive or negative. So we're going to make a little table here, and then the answer to these is your root. Okay? What kind of roots we get. So let's start off easy, right? What we're used to. What if we have an even index? Like a square root. All right. What type of radicand do we have to have? Positive, right? Has to be positive. Has to be a positive radicand. So just think about square roots. Remember back when we were solving with square roots? And we'd have x squared is equal to 4. And we would take the square root of both sides. How many answers would we get? We get 2, wouldn't we? Both positive and negative, right? We'd have positive and negative roots. Okay, so our roots, we would always get 2 roots. We would get 1 positive and 1 negative. Make sense? That you're used to doing. That's going to hold true for 4th roots, 4th, 6th, 8th, any even. Okay, so if your index is 2, 4, 6, 8, 10, 12, that's going to be the deal. And if your radicand is positive, and it has to be, then you're always going to have 2 roots. 1 positive, 1 negative. Now what about if you're dealing with an odd root? You're not limited to only a positive radicand. But what if it is a positive one? What type of a root would you have? Would it be both positive and negative? Would it be both, or would it just be positive?
Oh, hold on.
Think about if you're doing the cube root of 8.
Could be both.
Could it be both positive and negative? Well, let's think about it. What if we're saying it's both? So let's do 2 times 2 times 2. Does that equal 8? Okay, so it could be positive. What if it's negative 2 times negative 2 times negative 2? Does that equal positive 8? No. So it's only 1, and it's positive. Only 1 positive root. So when you have odd index, right? A 3, 5, 7. You're not looking at multiple roots. You're only looking at 1. And if it was a positive radicand, it's a positive root. But if you have an odd index and a negative radicand, you're going to have 1 negative root. So this is a nice little chart to keep with. Now, it should make sense to you. You shouldn't really need to keep a chart like this and refer to it. But it could be helpful if you're having a hard time, if you keep putting plus or minus by every single solving problem you do. You only have plus or minus roots when your index is what? Even. And if your index is odd, you're only going to have 1 answer. And it's dependent upon your radicand. If your radicand's positive, your answer is going to be positive. Radicand is negative, your answer is going to be negative. But there's only going to be 1 of them. So please keep that in mind. Make sense? Are you sure? Sí, señorita. Das ist gut.